Welcome to the module Graph Analysis. Here in the first lecture or in the first video, we show you about a few objectives and the literature we're using in this course. So the things we want to talk about here, besides the objectives and literatures, which is this video, is that we go into the next video where we talk from how we get from one knot to another knot. So please excuse this really bad pun that we implemented here, but we had to find a way to make the topic more fun, so we take low-hanging fruit jokes. We also talk about the largest connected components in a graph before we move on to global measures, where we talk about diameter, path length, and density of a graph. We move then on to more mathematically complex and difficult to follow concepts, but are still really, really important in graph theory and are extremely intuitive and implemented in all basic statistic software, which you use for graph analysis, which is eigenvector centrality, cat centrality. Centrality for hubs and authority is also really important when we want to look into the structure of a network, if it's reliable or not. We also have to talk about clustering and transitivity, and a really important aspect in real-life networks is resilience, so how shock resilient the graph or the network is to external disturbances. This whole online class is built pretty much on these 5 books. We already went over this linear algebra for dummies, which is a really great introduction there. But here we really work a lot and base our own material on the work by Sergeant Thomas and John Stokowski, 2024, Economic Networks, Theory and Computation. Mark Newman has a really brilliant book on networks. It's a really thick book, but it's worth the money. Same with Filippo Manzer, Santo Fernando, and Clayton Davis, first course in network science. Michel Cosquilla has a great atlas for the aspiring network scientist. And of course, Albert Laszlo's Barabasi network science book. Most of them are also available open source, so really easy to afford, $20, $30 if you want them as a print. So really, really recommend to look into them. Sure, the Mark Newman book on networks is a little bit more expensive, but it's still really worth the money and really detailed and easy to follow introductions. The graph interpretation basics we want to look into this whole video segment of Module 3 is you have to keep in mind that the choice of measures depends on the network, on the graph, and the problem you're analyzing. So not every tool we're telling you here is the adequate tool to apply once you have a network in front of you. It requires a little bit of, or a lot of understanding of the graph of the problem, which tool you're using. So it's the same like renovating your apartment or something like that. You have this whole toolbox of things you want to do, but you have to understand what you're going to do to use the right tool. If you have a hammer, it's absolutely useless because the task on hand is to paint the walls. So this is something where you can't use the tool just because it's in your toolbox. You have to really use the correct tools. And something I really like to stress here in all quantitative classes that I'm teaching is it's important to clarify explicitly which measures are chosen by you and why. So not just like, oh, I use this because it makes sense. No, tell me why it makes sense. You have to understand why it really, 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 really makes sense for you to use that in that specific moment. And if you do that in a convinced way, if you can convince me as your instructor, then you can convince everyone. Because it must make sense. You have to tell me why you're using the hammer to hammer in the nail into the wall. Well, because it transmits the force, it gets the nail into the wall, you hit it, perfect. And I'm like, yes, I believe you. So this is really important. Clarify what you're doing, why you're doing. And sounds a little bit like, oh my gosh, I don't want to do that. And how do I figure out which tool I want to use for which task? It's actually quite easy in graph theory because the mnemonics of the terms quite often tell you which concept to use. So if you think of it like, oh, I really want to know how I get from A to B, and how long that is. How do I measure that? The technical term for that is distance. So graph theory is a lot built on intuitive words, and sure, sometimes the mathematical concepts are a little bit difficult, but you easily know which one to use because it is quite intuitive. So with that, let's dive into the next video where we actually start working with graphs.